The deeper we stare into space, the stranger it becomes. Despite our charts, simulations, and models, the universe continues to surprise us. Sometimes it doesn't just surprise, it challenges the very foundations of what we thought we understood. Anomalies so bizarre that even the most seasoned scientists begin to question the rules of physics themselves. Among the most mysterious of these cosmic puzzles are something called FRBs, fast radio bursts. It began, almost silently, as a whisper. Just a tiny burst of radio energy, hidden in terabytes of data collected by radio telescopes. Astronomers nearly missed it. At first, it looked like interference, just noise in the data. But then there was another, and another. Each burst originated from a direction far beyond our own Milky Way galaxy. Each lasted only milliseconds, and yet each was unbelievably powerful. These weren't random static blips. These were deliberate, focused pulses of energy, brighter than anything we'd expect in such a short time frame. Just a few milliseconds long. But in that moment, they released more energy than our sun emits in an entire day. That's like hearing a match strike and realizing it just lit up an entire city. The first FRB ever discovered was labeled FRB 121102. What made it special? It repeated. Most cosmic bursts, gamma rays, supernovae, are one-time events. But FRB 121102 flared again, and again, and again. That single feature changed everything, because if it repeats, it's not the death of a star, it's not a one-off explosion, it's something else entirely. This signal, originating from a tiny, ancient dwarf galaxy nearly 3 billion light-years away, had a strange twist in its waveform. That twist hinted that the signal had passed through an intense magnetic environment, perhaps near a black hole, or something even stranger. Astronomers around the world, at observatories like CHIME, Arecibo, and Green Bank, rushed to observe it. And what they found stunned them. A pattern, a pulse, almost a rhythm. Could it be natural? Could it be artificial? They weren't ready to say. To this day, we've discovered hundreds of FRBs. Some are one-offs. Others, like FRB 111102, repeat. And one in particular, FRB 180916, appears to have a 16-day cycle. It pulses for 4 days, then it goes silent for 12. Then the cycle begins again. This level of regularity is unusual in astrophysics. In nature, chaos rules. But this feels like a clock, a transmission, something intentional. Still, no one knows for sure. Some scientists believe they come from neutron stars, ultra-dense stellar corpses spinning rapidly with intense magnetic fields. Others suggest magnetars, a rare type of neutron star with magnetic fields trillions of times stronger than Earth's. But there are also those who whisper of intelligence. Could FRBs be beacons? Could they be the interstellar equivalent of a lighthouse pulsing through the void? A galactic Morse code? No evidence confirms that, but none disproves it either. And that's what makes it so compelling. At Infinity Beyond, we explore these questions not to chase fantasy, but because they're real, documented, peer-reviewed, and still utterly unexplained. The universe is speaking in pulses. The only question is, are we ready to listen? Among the hundreds of fast radio bursts discovered, one stands apart. It doesn't just repeat, it repeats on a schedule. Meet FRB 10916, a radio signal from space that seems to operate with astonishing precision. Every 16.35 days, it flares up. For 4 days, it pulses with strange millisecond-long bursts. Then, it goes silent. For the next 12 days, not a single blip. Then it starts again, over and over, like clockwork. This behavior stunned astronomers. In a universe where most events are chaotic, random explosions, unpredictable movements, fading flashes. This signal felt different, almost mechanical. And that raised a very big question. Is this a natural object or something else entirely? To understand why FRB 180916 is so significant, let's rewind. Most FRBs are one-time events. They flash once, then never again. Some, like FRB 121102, repeat, but without any predictable pattern. So when scientists at the Canadian Chime Observatory noticed the 16-day cycle, it was a breakthrough. It wasn't just repeating, it was timing. Such precision in astrophysics is rare. Even pulsars, those rapidly spinning neutron stars that emit beams of radiation, can be a little irregular over time. But this signal? It was eerily reliable. And it wasn't weak. These bursts, even from a galaxy 500 million light-years away, were strong enough to be picked up on Earth. That implies incredible power. Or incredible focus. So what could it be? Some scientists think it may come from a neutron star orbiting a massive companion, like a black hole. As the neutron star swings closer, its radio beam is briefly visible from Earth. Then, as it moves away, the signal disappears. That could explain the cycle. Others suggest a magnetar, a neutron star with an extremely strong magnetic field, trapped in a dense stellar wind that blocks the signal for part of its orbit. These are plausible, but they're not confirmed. And that uncertainty has opened the door to wilder ideas. What if we're not seeing a natural process? What if the signal is a beacon designed to repeat on purpose? Not randomly, not chaotically, but with intent. Could an advanced civilization be transmitting across the stars, trying to get attention? Is FRB 180916 a cosmic lighthouse? Of course, there's no proof of alien technology, but there's also no law in science that forbids the question. As Carl Sagan once said, extraordinary claims require extraordinary evidence. And we don't have that yet. But here's the thing. We're getting better at listening. New arrays of radio telescopes, like the Square Kilometre Array, will soon be able to scan the sky with unprecedented sensitivity. They might pick up more signals like FRB 180916. They might even detect patterns within the pulses. Modulation, encoding, information. And if they do, then everything changes. At Infinity Beyond, we believe mystery is the first step toward understanding. FRB 180916 might be a natural wonder, or it might be a whisper from the stars. Either way, it challenges us to keep looking, to keep questioning, to keep listening, because the cosmos isn't silent. Sometimes it speaks with rhythm, and sometimes it feels like it's speaking to us. So far, we've talked about fast radio bursts, those sudden, powerful signals from distant galaxies. But now the mystery deepens, because scientists have discovered twists in the waves themselves. Not just flashes of energy, not just bursts of light, but patterns, distortions that suggest these signals have passed through something unusual. When astronomers studied FRB 121102 more closely, they found that the signal had been twisted, almost like it was spun around on its journey through space. What could do that? The answer? A powerful magnetic field, stronger than anything we typically find in empty space. Something nearby had warped the signal, bent it, as if the signal had traveled through the stormy environment of a black hole, or even worse, a magnetar on steroids. That discovery changed everything, because this wasn't just a clean signal shot through the cosmos. It was a message that had been scarred by its path, and those scars might tell us where it came from. Let's break that down. When a radio signal moves through a magnetic field, it undergoes something called Faraday rotation. It's like watching a spinning coin wobble as it moves across a table. It starts to tilt. It changes direction slightly. The light gets twisted. The stronger the magnetic field, the greater the twist. And in the case of FRB 2.2, the twist was off the charts. To get that level of distortion, the signal must have passed through an insanely intense magnetic environment. Some suggest it's trapped near the event horizon of a supermassive black hole. Others think it's nestled inside a dense, turbulent nebula left behind by a supernova explosion. Wherever it is, it's not quiet. But there's more. These bursts aren't just strong and twisted. Some of them are polarized. That means the waves are aligned, a level of organization that's rare in nature. It hints at order, at structure, almost like they were crafted. Could it still be natural? Absolutely. But the line between natural and intentional begins to blur when patterns appear, especially when those patterns come from billions of light years away. And that leads us to the next big mystery. Why are so many FRBs coming from dwarf galaxies? Tiny, ancient galaxies, billions of years old, seem to be the prime location for these bursts. Why? Is there something unique about those galaxies? A different kind of star? A different kind of environment? Or is it that someone or something in those galaxies wants to be heard? The theories are still developing, but what we do know is this. These signals are not just static noise. They are rich with information, not just in what they say, but in how they travel. Every twist, every polarization, every repetition, it all tells a story, and we're just learning how to read it. At Infinity Beyond, we believe the universe is not silent. It's just subtle. We need better tools, sharper minds, and the courage to ask uncomfortable questions. Because somewhere out there, something is speaking. And whether it's a collapsing star, a magnetar, or an ancient intelligence, we intend to listen. To hear the universe, you don't need a microphone. You need giant ears made of steel, dish-shaped, and tuned not to sound, but to radio waves. Across the world, massive radio telescopes have been quietly scanning the sky. They don't capture images, they capture data, bursts, waves, signals, and sometimes whispers from the void. In the quest to understand mysterious phenomena like FRBs, these telescopes are our best hope. They are the cosmic listeners spread across Earth, tuned into the heartbeat of the universe. One of the most important is CHIME, the Canadian Hydrogen Intensity Mapping Experiment. Located in British Columbia, CHIME wasn't originally designed to find FRBs. It was built to study the expansion of the universe. But by sheer design and sensitivity, it became one of the most prolific FRB detectors ever created. CHIME listens to a massive portion of the sky simultaneously. While traditional telescopes swivel and point, CHIME just sits still and lets the sky move over it. Every day, it gathers terabytes of information, sifting through it with AI and machine learning to find the telltale burst of an FRB hiding among the noise. It has discovered dozens of new FRBs, some that repeat, some that don't, and some that challenge everything we know. Then there's Arecibo. Before its unfortunate collapse in 2020, the Arecibo Observatory in Puerto Rico was one of the largest and most powerful radio telescopes in the world. Arecibo helped pinpoint FRB 21102. Its massive 305-meter dish acted like a magnifying ear, zooming in on the exact galaxy the signal came from, an old, faint dwarf galaxy billions of light-years away. But Arecibo did more than detect. It helped decode. By studying the twists, delays, and polarization in the signal, scientists began to map the path that signal had traveled, and the environment it had passed through. Even now, its legacy lives on in the data it left behind. And then there's Green Bank, nestled in the quiet zone of West Virginia, USA. Green Bank is unique. It's located in one of the few places on Earth where wireless signals are banned. No Wi-Fi, no cell towers, no radio interference. Why? because even the tiniest Earth-based signal can drown out whispers from space. Here in this silence, the Green Bank telescope reaches into deep time, searching not just for FRBs, but for intelligence. It's one of the observatories used in the Breakthrough Listen project, aimed at detecting extraterrestrial signals. Not natural pulses, but artificial patterns. Green Bank has already helped confirm dozens of FRBs, and it continues to scan for anything unusual, anything structured. Together, these observatories form a global network of ears, each one tuned to different parts of the sky, each one filtering, comparing, verifying. It's a silent symphony, data dancing across the Earth in cables and satellites, routed through computers and algorithms in search of meaning. And as our detection power grows, so does the complexity of what we find. These telescopes are showing us that the universe is active, not still, not quiet. It's alive with energy, with patterns, with possibility. From Canada to Puerto Rico to West Virginia and beyond, Earth has become a planet that listens. And what we're hearing is changing us. At Infinity Beyond, we celebrate these silent giants, the unsung heroes of discovery, the dishes in the dark that brought us signals from across billions of light years. Because it's not always about looking up. Sometimes the universe speaks in ways you can only hear. And we're finally starting to understand the language. We live in the noisiest time in human history. Notifications, traffic, news feeds. But ironically, the greatest discoveries are being made by listening to silence. The universe speaks in faint whispers, and to hear them, we need more than telescopes. We need algorithms. We need AI. In the past, radio telescopes gathered data faster than humans could process. Entire archives sat untouched, terabytes of unexplored signals. Some bursts were simply missed, others misunderstood. That changed when we brought in artificial intelligence. Today, AI systems are trained to recognize anomalies, bursts of radio energy, repeating signals, unusual polarizations, things that once took humans weeks to confirm. Now they're flagged in seconds. AI doesn't sleep, it doesn't get bored, and most importantly, it never stops listening. Projects like CHIME, FRB, Breakthrough Listen, and future observatories like the Square Kilometre Array, SKA, use AI not just to search, but to learn. With every signal detected, the system gets smarter. It recognizes patterns. It remembers noise, so it can focus on signal. It begins to understand the voice of the universe. And in that voice, we've started to hear things that don't belong. Signals that repeat but don't come from pulsars. Bursts that follow mathematical structures. Blips buried in years-old data, suddenly brought to light. In 2021, a graduate student used machine learning to reanalyze old data and found over 70 new FRBs that had been missed. They were always there. We just didn't see them until the machines taught us how to look. It's humbling, because for centuries we thought of telescopes as the eyes of astronomy. But now, our most important sense might be ears, paired with code. AI is helping us filter the chaos of the cosmos, to find the needle not just in one haystack, but in billions of haystacks, stacked across light years of space. But with great power comes great responsibility. We must ensure that AI doesn't just detect patterns, but that we humans interpret them correctly. Is that repeating signal a magnetar? A neutron star? A galaxy glitch? Or is it communication? AI can point, but we must decide what it means. And that's where human curiosity comes in. Because science isn't just about data, it's about wonder. At Infinity Beyond, we believe in the partnership between man and machine. The telescope hears, the AI deciphers, the human asks why. Together, this triad is reshaping how we see the cosmos, not as a void, but as a dynamic speaking system. And perhaps, as AI gets smarter, it will hear something we've never heard before. A pattern, a sequence, a signal, one that doesn't fit. And when that day comes, we'll be ready. Not because we predicted it, but because we trained ourselves to listen. We are no longer just looking for aliens. We are looking for answers about ourselves, about physics, about the limits of what's possible. Because when machines teach us how to hear the universe, they might also teach us how to understand our place in it. This is Infinity Beyond, where silence is not empty. It's full of possibility. The universe is vast, so vast, in fact, that it's hard to believe we're the only ones here. And when mysterious, powerful radio signals started pouring in from deep space, brief, repeating, energetic, some scientists began to ask, what if these aren't just cosmic phenomena, but messages? What if someone, something, is trying to get our attention? Let's be clear, there is no confirmed evidence that FRBs are artificial. They could be natural. They probably are. But let's entertain the possibility, just for a moment. Because if someone was trying to contact us, what would it look like? It wouldn't be voice. It wouldn't be video. It would be energy, something that could travel billions of light years and still be detectable. Something simple, repeatable, structured, like a radio pulse. Exactly like an FRB, the repeating nature of signals like FRB 121102 and FRB 180916 has raised eyebrows. A 16-day cycle, bursts with polarization. Signals twisted as if they'd passed through complex electromagnetic fields. And now, even possible clustering, groups of FRBs emerging from similar regions of space. Some theorists propose that if a civilization wanted to communicate across galaxies, it wouldn't send constant streams. It would send short, high-power bursts, like Morse code on a cosmic scale. And if we were only just learning to detect these bursts now, what else might we be missing? Enter the beacon hypothesis. The idea is simple. An intelligent civilization might build a powerful transmitter, something orbiting a star, perhaps, to send signals in all directions, hoping someone's listening. It might repeat at regular intervals. It might contain structured modulation, changes in waveforms that represent language or math. We haven't found any clear message in FRBs yet. But here's the catch. We don't yet know what to look for. Imagine giving Shakespeare to a dog. The meaning is there, but the ability to decode it isn't. If FRBs are messages, the encoding could be far beyond anything our current systems can detect. But that hasn't stopped us from trying. Projects like Breakthrough Listen have begun to examine FRB data through the lens of artificiality, looking for non-random structures, mathematical ratios, repeated patterns that might suggest intent. So far, nothing definitive, but the very fact that we're asking these questions is remarkable. It means humanity is ready to look beyond stars and planets and start searching for minds. Of course, there's pushback. Many scientists warn against jumping to conclusions. They point to magnetars, plasma lenses, neutron-star collisions, all fascinating, violent processes that can create the same kinds of signals. And they're right to be cautious, because science isn't about believing, it's about testing. But curiosity is where discovery begins. And at Infinity Beyond, we believe that asking bold questions doesn't weaken science. It drives it forward. So, what if? What if we're already receiving messages from civilizations so advanced we don't even recognize the format? What if every FRB is a line in a long cosmic conversation? Maybe one day we'll learn to reply. Or maybe they already know we're listening. The sky is not silent, and maybe neither is the void. We've heard the signals. We've tracked their cycles. We've questioned if they might be messages. But now comes a deeper mystery. Where are these fast radio bursts actually coming from? If we can trace them back to their birthplaces, we may unlock one of the most profound puzzles in modern astronomy. And surprisingly, many of these signals are pointing to dwarf galaxies. Unlike massive spiral galaxies like the Milky Way, dwarf galaxies are small, faint, and often overlooked. But they're ancient, relics of the early universe. And they seem to be hotspots for repeating FRBs. Take FRB 121102, for example. After years of pinpointing, astronomers traced it back to a tiny dwarf galaxy over 3 billion light-years away. Why there? What is it about these low-mass, low-metallicity environments that produces such energetic bursts? Some researchers believe it's because dwarf galaxies are more likely to host young magnetars, highly magnetized neutron stars born from massive supernova explosions. A magnetar is no ordinary object. Imagine a collapsed star, only a few kilometers wide, with a magnetic field 1,000 trillion times stronger than Earth's. These monsters can twist and snap their magnetic field lines, releasing immense energy, including bursts of radio waves that match the profile of FRBs. It's like a cosmic tantrum, and it might explain the sheer power behind each flash. But not all FRBs fit that model. Some bursts come from massive galaxies or regions near black holes, where conditions are far more chaotic. Others show signs of passing through dense plasma, indicating they may be embedded in stellar nurseries, or remnants of ancient supernovae. Each signal tells a slightly different story. So what do all these clues suggest? That there might not be one single origin for FRBs. Instead, we could be looking at multiple astrophysical processes, some explosive, some rotational, some magnetic, all producing similar-looking bursts across different cosmic environments. It's as if the universe has more than one way of shouting, and we're only now learning to listen to the accents. The diversity of FRB locations also opens the door to something even more intriguing. If there are different sources, could one of them be unnatural? A cosmic beacon built inside a dwarf galaxy? A signal sent from the chaotic edge of a black hole? A technology designed to blend in with cosmic noise? We don't know, but the more varied the sources, the more complex the puzzle becomes. And that's what makes this field so exciting. Astronomers are now building detailed maps of the sky, not just to spot FRBs, but to track them, triangulate them, and learn from their environment. By examining how the signal bends, slows, or rotates as it travels, we can reconstruct what lies along its path. Each burst is like an X-ray, and the cosmos is our patient. At Infinity Beyond, we believe that understanding where something comes from is often the key to understanding why it exists at all. These FRBs may not just be flashes. They might be stories. Stories of stars collapsing, fields twisting, space curving, and perhaps, just perhaps, civilizations calling. So keep watching, keep listening, because every time the sky flickers with a new FRB, a new chapter begins. Science thrives on mystery. And fast radio bursts, those brilliant millisecond-long pulses from across the universe, are among the most debated cosmic riddles of our time. The deeper we dig, the more fragmented the theories become. Some say the answer lies in extreme astrophysics. Others whisper of alien civilizations. So where does the truth lie? Let's dive into the great scientific debate surrounding the origins of FRBs. On one side, we have the naturalists. These are astrophysicists who argue that FRBs are simply high-energy products of known cosmic phenomena. Their top suspects? Magnetars, young neutron stars with insane magnetic fields that occasionally release bursts of gamma and radio waves. Merging neutron stars, collisions that release gravitational waves, and, potentially FRBs as a byproduct. Black hole interactions, intense regions where matter behaves chaotically, possibly creating burst-like emissions. Supernova remnants, ancient stellar corpses in chaotic environments, could also be candidates. These theories are grounded, testable, and supported by computer simulations and observations. And yet, they don't explain everything. Enter the anomalies. Some FRBs repeat, some don't. Some come in clusters. Some travel through strange media that alter their signature. And then there are those with no clear origin. Signals that seem to come from empty regions of space, bursts with strange polarization patterns, or those that follow unusual periodic cycles. These outliers have opened the door to alternative thinking. Some scientists propose exotic physics, like cosmic strings, dark matter interactions, or even primordial black holes. But others ask, what if intelligence is involved? What if some FRBs aren't accidents, but intended transmissions? This doesn't mean aliens in the sci-fi sense. It means acknowledging the possibility that advanced civilizations, if they exist, might use technologies or astrophysical structures to communicate, or simply exist in a way that generates such bursts. Could a Dyson sphere glitch create a detectable signal? Could an alien probe use radio bursts to transmit data across galaxies? While speculative, these ideas are gaining more academic space, not because they're proven, but because current models don't explain everything. The beauty of science is not in having all the answers. It's in the courage to ask better questions. And right now, the questions are evolving. Is the FRB distribution across space truly random? Do the repeating ones show intelligence-like structure? Are we looking at multiple unrelated phenomena bundled under one label? Or are we simply not yet wise enough to see the pattern? At Infinity Beyond, we believe that opposing ideas are not signs of confusion, but signs of growth. When science splits into factions, naturalists, exoticists, theorists, it means the data is pressing against the boundaries of what we know. And that's when revolutions happen. Think about the first pulsars. When Jocelyn Bell discovered them in 1967, their signals were so regular they were dubbed LGM, Little Green Men. They turned out to be neutron stars, but the curiosity behind the question was never wrong. The same may be true for FRBs. Natural? Artificial? Or something else entirely? Right now, no one can say for sure. But every day, new data arrives, and with it, a clearer picture. Not of the answer, but of the questions worth asking. When we talk about the search for alien life, most people imagine messages, signals beamed across the stars, saying, "We are here." But what if the signs of alien life aren't messages at all? What if they're byproducts of advanced technology? What if the universe is filled not with greetings, but with techno-signatures? Fast radio bursts, or FRBs, are one of the most tantalizing candidates. They're powerful, they're mysterious, and some scientists believe they might not be natural. Let's unpack this idea. A technosignature is any observable effect or signal that could indicate the presence of technology. It doesn't need to be intentional. It could be a waste signal, a navigation pulse, a communication ping between distant probes, or perhaps a propulsion system. Yes, some researchers have proposed that FRBs could be radiation leakage from light sails used to move spacecraft at relativistic speeds. Imagine a massive alien craft driven by a laser array. As the beam hits the sail, it pushes the ship, and some of that energy leaks sideways into space. From our vantage point, billions of light years away, it would look like a short, intense radio burst. Just like an FRB. In 2017, two Harvard researchers explored this very idea. They calculated that if an alien civilization were using gigantic beam-driven propulsion, The radiation spillover could be detected from Earth as FRBs, not as a message, but as evidence of engineering. It's a bold theory, but it forces us to widen our definition of what alien life might look like. Not little green men, but big energy footprints. This opens the door to a broader field, Dysonian SETI. Unlike traditional SETI, which looks for intentional radio messages, Dysonian SETI looks for indirect evidence, heat signatures, artificial structures, power emissions, and, yes, unexplained bursts of energy. What makes FRBs especially intriguing is their scale. Each burst releases as much energy in a millisecond as the sun does in days. That's not easy to produce, even for natural objects. But for a Type 2 or Type 3 civilization on the Kardashev scale, it might be routine. So how would we know if an FRB is artificial? This is the hard part. We'd look for patterns, mathematical sequences, uniform modulation, consistent cycles. We'd analyze polarization, timing, and repetition. But here's the catch. If the technology is truly alien, it may not follow our logic. We might be watching the equivalent of a cosmic data transmission and not even realize it's intelligent. Like watching Morse code without knowing Morse exists. Some skeptics dismiss these ideas as science fiction. And fair enough, extraordinary claims require extraordinary evidence. But here's the truth. Science progresses by exploring edges, by following anomalies, by asking what else could be true. And FRBs are the ultimate anomaly. They defy easy classification. They show diversity that natural models struggle to explain, and they keep surprising us. Is it possible some are from magnetars? Absolutely. But is it possible others are something else? That's the question we must keep alive. At Infinity Beyond, we believe that imagination is not the enemy of science. It is its engine. So as we listen for bursts in the night, we're not just collecting data. We're testing the boundaries of what life can be. And maybe, one day soon, we'll find the techno-signature that changes everything. Not a message, but a mistake. A whisper from a civilization that never meant to be heard. And in that whisper, we may finally find our place in the cosmos. When we think of alien life, most of us imagine something vaguely humanoid. 2 arms, 2 legs, maybe big black eyes. But what if life beyond Earth isn't just strange? What if it's unrecognizable? The universe doesn't owe us familiarity. And as we widen our search, it's time to let go of human-shaped assumptions. Because alien life might not just live in different environments. It might be built on different rules. Let's start with biochemistry. Here on Earth, all life is carbon-based. It relies on water as a solvent, DNA for information storage, and proteins to function. But other planets might not offer the same conditions. Some scientists have proposed life based on silicon, a chemically similar element to carbon. Silicon forms complex chains too, and under different temperatures and pressures, it might serve as the backbone of alien cells. Other theories suggest ammonia-based life, or even creatures that rely on methane, sulfur, or hydrocarbons instead of water. We've already found lakes of methane on Titan, one of Saturn's moons. Could something live there? Then there's extremophiles, life on Earth that thrives in what we once thought were uninhabitable places. Boiling acidic springs, crushing oceanic depths, radioactive caves, even clouds of sulfuric acid. These organisms prove that life doesn't need perfect conditions. It just needs adaptation. So when we look at other planets, we shouldn't just ask, could humans live there? We should ask, could something else? And maybe the weirdest possibility? Non-biological life. What if intelligence doesn't emerge from cells at all? What if somewhere out there, life evolved straight into machines? Not built by others, but self-evolved AI, organic intelligence giving birth to technological successors. If that's the case, then our search for microbes on exoplanets might be too limited. We might need to listen for data patterns, digital artifacts, or energy signatures, not just biosignatures. This shifts the conversation from "Are we alone?" to "Are we even asking the right questions?" Astronomers now use the term life as we don't know it to capture these ideas. It's not just science fiction. It's an acknowledgement that our imagination may be too small for the universe we live in. If alien life exists, it might communicate in chemicals, not sound. It might think in magnetic pulses, not language. It might not even understand time the way we do. And that's okay. At Infinity Beyond, we believe that being humble in our expectations is key to finding the unexpected. The cosmos isn't just strange, it's stranger than we can imagine. And in that vastness, the definition of life may be as broad and diverse as the galaxies themselves. So as we build new telescopes, launch new missions, and listen to the stars, let's also open our minds. Because alien life might be closer, weirder, and more wondrous than anything we've ever dreamed. We've built telescopes, we've scanned the skies, we've sent signals into the void, and still, nothing answers. The silence is deafening. But what if the problem isn't that no one's out there? What if we're simply listening the wrong way? For decades, scientists have searched for alien life by listening, using giant radio dishes to detect messages from distant stars. This is the heart of SETI, the search for extraterrestrial intelligence. But what if aliens don't use radio at all? What if their messages don't sound like anything we'd recognize? Let's think about how fast our own technology has evolved. A century ago, we were just learning to use radio. Today, most of our communication happens digitally, through fiber optics, satellites, and encrypted signals. To an outsider, Earth may already seem silent. So why would an alien civilization use radio just so we could hear them? They might be communicating in light pulses, quantum signals, or even gravitational waves, forms of transmission we're only beginning to understand. That's why scientists today are expanding the search. Projects like Breakthrough Listen scan not just for radio, but for optical bursts, short flashes of laser light that could be signals. Others are building algorithms to search for techno-signatures, indirect signs of technology, like city lights, atmospheric pollution, or unexplained energy bursts. Every new telescope, from the James Webb Space Telescope to the upcoming Extremely Large Telescope, brings better tools to detect possible signs of life. But even then, we might miss the message, because it might not come as a message at all. That's where the concept of passive evidence becomes powerful. Imagine finding a planet with oxygen and methane in its atmosphere, gases that usually don't coexist unless life is replenishing them. Or detecting night-side illumination, like artificial lights on the dark side of an exoplanet. These are not signals, they're side effects, clues, whispers of intelligence that never intended to be found. But maybe the problem isn't the message. Maybe it's the timing. The universe is 13.8 billion years old. Human radio technology has existed for about 100 years. What if civilizations rise and fall like sparks in the dark? What if they broadcast for a few centuries, then go silent, just before or after we're listening? We may be looking for ghosts, or being looked at by those who've already passed by. Still, we listen, because silence itself is information. It tells us that intelligence is either rare, quiet, or unreachable, and each possibility reshapes how we see our place in the cosmos. At Infinity Beyond, we believe in listening better, not louder, not longer, but smarter, using new tools, new thinking, and the humility to admit we might not know what to expect. So are we listening the wrong way? Maybe, but every scan, every search, every unanswered call brings us closer to asking the right question. And sometimes that's all it takes. For centuries, we've searched the stars. But what if we are the ones being watched? What if alien civilizations have already discovered Earth, quietly, patiently observing us from a distance? It's not science fiction. It's a serious scientific possibility. This idea is known as the zoo hypothesis, and it asks a simple but haunting question. What if we're not alone, but simply ignored? Let's explore. Imagine a highly advanced civilization, capable of interstellar travel, data collection, and stealth observation. Such beings might have discovered Earth millions of years ago. They could be monitoring us with cloaked probes, orbiting just beyond the moon, or hiding in the asteroid belt. Some even suggest that alien artifacts could be on Earth itself, buried, dormant, or camouflaged so well we've never noticed. And what if they're watching not to interfere, but to study? Like biologists observing animals in the wild, they may choose to remain unseen, allowing us to evolve naturally. Hence, the name, the zoo hypothesis. It's a chilling but logical extension of the Fermi paradox, the question of why, in such a vast universe, we haven't detected alien life. The answer might be, we have. We just don't know it. Or more accurately, they've detected us and chosen not to respond. This theory forces us to reconsider what contact looks like. We often expect a grand arrival, ships in the sky, universal greetings, but real contact might be silent, covert, ongoing. They could be listening to our broadcasts, monitoring our environmental changes, analyzing our behavior. And if they've been watching us since before we invented fire, they might know more about humanity than we do. Some scientists have proposed specific search strategies to test this theory. Looking for non-random anomalies in satellite orbits, scanning for reflective objects in Lagrange points, even inspecting asteroids for unnatural structures or materials. The goal? To find evidence of surveillance. Because if we're under observation, there should be signs, if we know where and how to look. And here's the twist. Would we even recognize alien surveillance? It might not look like a camera or a satellite. It could be a tiny quantum sensor, a neutrino-based detector, or even a biological construct seeded onto Earth millennia ago. We may be living among the very tools of our watchers and not even know it. At Infinity Beyond, we believe in confronting uncomfortable possibilities. Because whether it's FRBs, technosignatures, or eerie silence, every piece of the puzzle could be part of a greater picture. That we're not alone, and never have been. So have aliens already found us? We may never know for sure. But perhaps the better question is, what would we do if we were them? Would we reveal ourselves? Or would we observe silently, waiting for the right moment? Maybe that moment is now. What if the stars are whispering, not from the present, but from a past long gone? Imagine this. A civilization rises, invents radio, sends signals into space. They build monuments, power grids, satellites, and then disaster. A war, a gamma ray burst, climate collapse. And in a blink, they vanish, but their footprints remain. Their light still travels. Their signals still echo. Their artifacts still orbit dead stars. We may not be searching for living aliens. We may be chasing ghosts. This idea is known as the archaeology of the cosmos. Instead of listening for conversations, we sift through space for evidence of lost civilizations, dead worlds, forgotten messages, abandoned megastructures. Some scientists believe that at least a few alien species have already come and gone, and what's left behind could be waiting for us to discover. One example? The search for Dyson spheres, hypothetical structures built around stars to harness all their energy. If a civilization attempted this and failed, remnants of the structure might still block parts of starlight, creating unusual dimming patterns. Telescopes like Kepler and James Webb are now watching for such irregularities. And when they find them, we must ask, is this just dust? Or a technological tombstone? Or consider radio signals, FRBs, strange pulses, narrowband bursts. Some may not be alive in origin. They could be artifacts, relics from civilizations that sent them millennia ago. Because of the vastness of space, a message sent 10,000 years ago might only reach us today. And when we receive it, the sender may no longer exist. It's the ultimate cosmic tragedy. A hello arriving after the goodbye. Even planets themselves may carry signs. Atmospheric chemicals, land alterations, orbital debris, all potential markers of an extinct civilization. Think of Mars. What if its canyons, dry riverbeds, or magnetic anomalies aren't just geology, but evidence? We may already be standing on ancient ruins and not realize it. This search requires a shift in mindset. We're not just looking for life, we're looking for death. But not in despair, in wonder, because the story of a lost civilization is still a story, a message, a mirror, and by studying them, we may learn how to avoid the same fate. At Infinity Beyond, we believe that space is not just a frontier, it's a library, and every planet, every star, every anomaly could be a page from a forgotten chapter. So as we stare into the darkness, let us remember, some lights may have gone out, but their glow continues, and perhaps that's how they'll live on. Imagine walking through a dark forest at night. You hear nothing, see nothing, but you feel it, eyes watching from behind the trees. You don't shout, you don't make a sound, because in the dark, the first to speak may be the first to die. Now imagine that forest is the universe, and every star is a tree hiding a potential civilization. This is the essence of the dark forest theory, and it might be the most terrifying explanation for why the cosmos is so silent. First proposed by science fiction author Liu Cixin in The Three-Body Problem, the theory is now taken seriously by some scientists and futurists. Its logic is chillingly simple. All civilizations want to survive, but they can't be sure of each other's intentions. So the safest move is to stay hidden. Or worse, strike first. Let's say two civilizations find each other. How can either side be sure the other won't become a threat? Even peaceful intentions can change over time. And if one gains too much power, the balance is lost. So in a universe with no second chances, the logical move may be elimination. Better to destroy than be destroyed. Better to hide than be found. This theory paints the universe not as empty, but as full of life, all of it hiding, which would explain why SETI hears nothing, why no probes arrive, why alien megastructures are never seen, because everyone is playing the same deadly game of cosmic silence. And humanity? We've already made noise. In the last 100 years, Earth has leaked TV signals, radar pulses, and spacecraft telemetry into space. We've even sent deliberate messages, the Arecibo transmission, the Voyager Golden Records, the MET broadcasts. To a cautious civilization, these may be red flags. Imagine a world hearing our signals and thinking, they're young, loud, technologically rising, and careless. Would they respond? Or would they mark us as a threat? That's the danger of the dark forest. By calling out into the unknown, we may be inviting attention we're not ready for. Some scientists have even called for a moratorium on active messaging, warning that we don't yet understand the consequences. Others argue that if everyone stays silent, we may never connect. So what's worse, being found or staying alone? The theory also raises moral questions. Should we assume the worst of others? Should we prepare to fight before we even meet? Or should we trust that intelligence comes with empathy? At Infinity Beyond, we believe the answer lies in understanding risk, not fear-mongering. Because true curiosity means accepting that some truths are uncomfortable. Maybe the universe isn't quiet because it's empty. Maybe it's quiet because everyone is terrified. And if that's true, then every signal we send isn't just a greeting. It's a flare in the dark, a gamble, a test. And the response, if it comes, may not be what we hope. We look to the stars, searching for signs of life, but we see nothing. No civilizations, no signals, no visitors. The galaxy should be teeming with activity. So where is everyone? One explanation is more terrifying than any alien invasion. It's called the Great Filter. The Great Filter is a concept that tries to answer the Fermi paradox, the contradiction between the high probability of intelligent life and the total silence we observe. It suggests that somewhere along the path from simple life to interstellar civilizations, there's a barrier, a step so difficult, so deadly, that almost no one makes it through. If true, then intelligent life is rare, not because it never forms, but because it rarely survives. Let's break down the steps. Formation of habitable planets, emergence of single-cell life, evolution to complex life, intelligence, tool use, civilization, advanced technology, space exploration, long-term survival. The Great Filter could be behind us, meaning that life rarely gets past the microbial stage, and we are incredibly lucky. Or it could be ahead of us, which means we are on a path that almost always leads to self-destruction. This is where the theory gets dark. If humanity is typical and the universe is silent, it may be because most civilizations destroy themselves through war, climate collapse, AI gone wrong, or other catastrophes. Every silent planet we find could be a grave marker, a reminder of how far others got and how far we still have to go. But if we're rare, if we've already passed the filter, then we might be one of the first to reach this point. That would be cause for celebration. It would make Earth the crown jewel of the cosmos, proof that intelligence can survive. But if the filter is still to come, then every step forward is a step closer to danger. The development of nuclear weapons, biotechnology, uncontrolled AI, these may not just be milestones. They may be traps. This is why many scientists and futurists believe we must tread carefully, not just to explore the stars, but to survive them, to prove that it's possible to go beyond the filter, to become not just a civilization, but a cosmic survivor. At infinity, beyond, we explore not just what's out there, but what it means to get there. Because space isn't just a destination, it's a test. And the final question may be, are we the answer? Or just one more failed experiment? So what is the Great Filter? A wall we already broke through? Or a cliff we haven't seen yet? Either way, the stakes couldn't be higher. Because in this cosmic story, we're either the lucky exception or the next to fall. What if the silence of the universe is not the absence of others, but the aftermath of their extinction? What if humanity is not one among many, but the last one standing? This is a chilling idea, a universe once teeming with life, now quiet. Not because life failed to emerge, but because it couldn't survive long enough. And now, it may be our turn. Some scientists believe we are late arrivals to a cosmic party that already ended. Civilizations may have flourished billions of years ago, long before Earth even cooled. They might have developed technology, colonized stars, and eventually destroyed themselves. By war, by runaway AI, by consuming their planets, by unlocking powers they couldn't control. Each one a cautionary tale, each one a chapter lost in time. If this is true, then Earth isn't just a planet. It's a miracle, a last breath of intelligence in a fading universe. And that makes our actions more important than ever, because the future of consciousness itself may depend on us. This idea connects to the rare Earth hypothesis, the belief that intelligent life is extremely rare, even in a galaxy with billions of stars. It's not just that life is hard to start, it's that surviving intelligence is even harder. Think about how many times humanity has almost ended. Global wars, climate crisis, nuclear standoff, pandemics, artificial intelligence risks. We've danced on the edge of destruction. And somehow, so far, we've survived. But for how long? If we are the last civilization, then every decision matters. Every scientific breakthrough, every war averted, every technology controlled, every effort to preserve our planet may determine whether the universe keeps thinking or goes silent forever. And yet, there's a strange beauty in this burden, because maybe we're the ones meant to carry the light forward, to seed the stars, to archive all knowledge, to send signals that say, "We made it, you weren't alone." And maybe, just maybe, someone, somewhere will hear it. At Infinity Beyond, we don't just ask if aliens exist, we ask what it means if they don't. Because in the quiet, we find clarity, and in solitude, we find purpose. So are we alone? Or are we the last spark in a dark, forgotten forest? If so, the silence isn't frightening, it's sacred. Because we don't just inherit Earth, we inherit the legacy of every mind that ever looked at the stars and failed to survive them.